Okay, welcome back. We have finished Unit 2, and we are now going to start Unit 3. Unit 2 was all about graphing quadratic equations. Unit 3 is about solving them without graphing. Now I'm going to make some connections. This page that's on the screen right now is not a part of your notes, but I want you to try to connect the previous unit to the upcoming unit. So in the previous unit, we learned that when we graph quadratics, we get a parabola, right? We could get a parabola that opens up, and it's going to cross here this x-axis twice. So it has two solutions. You can have a parabola. It can open it down or up, but it can have where it crosses the x-axis just one time or touches the x-axis just one time. And that's an example of no solution, or one solution. And then finally, we can have the parabola that floats above the x-axis or below the x-axis, and that's an example of no real solutions. When we're talking about parent functions, when it was talking about the maximum number of zeros, the word maximum tells us the maximum possibility. Here, when we're talking about solutions, we're talking about the actual graph that we're given. So if we're going to make a connection, just to remind us, what we did in this last unit is we had an equation, and from that equation, we graphed it. We used this equation to find our vertex. We would use the axis of symmetry to say negative b over 2 times a. That would give me x is negative 1. That's my vertex's point. I know it's negative 1, comma, and to find the y value, I'm going to plug that negative 1 into all my x locations, and that'll tell me what y is. 1 minus 2 minus 3, so that's 1 minus 5, so negative 4. So our vertex is negative 1, negative 4. From there, we'd find our other points. If I plug in 0, I'm going to be at negative 3. If I plug in 1, I'm going to be at 0. So here's what my parabola is going to look like. And it crosses the x-axis in 2 locations. So the solutions is a list of all the numbers. It crosses at negative 3, and then it crosses again at positive 1. So the 2 answers are the x values that it crosses. Now, we did this all last unit by graphing. What we were actually finding were these solutions, but we were just practicing the graphing and some of those questions. Now, what we're going to do in this unit is we're going to learn how to solve an equation like this, but without graphing it. We're going to get these answers we just came up with, but we're going to do it algebraically. So that is what all Unit 3 is about. So this is the beginning of Unit 3. This is Lesson 1. We're going to do a factoring refresher. In Algebra 1, you would have learned to factor. Factor is the opposite of the distributive property. So if the distributive property is multiplication, factoring is division. The first type of factoring you would have learned is how to find a greatest common factor, or a GCF. When you're finding a greatest common factor, you're looking for the biggest possible number and the maximum amount of variables that I can factor out of all the terms. In problem number 1, I have 2 terms. One term is 12k, the other term is negative 18. What I need to do is, what is the biggest possible number that I can factor out of this 12k minus 18? That's what I'm looking for. So the biggest number that I can factor out of these two would be 6. 6 can divide out of 12. I'm going to write 6, and then I'm going to open a parentheses, and then I'm going to divide. I'm going to take 12k, and I'm going to divide it by 6. What's left over, I write it inside my parentheses. So 12k divided by 6 would be 2k. Then I'm going to do negative 18 divided by 6. Negative 18 divided by 6 is negative 3. And that is my factored form, 6 times, without all the highlighting, 6 times the parentheses of 12k minus 3. That is our factored form. Okay. Repeating the process. Not only can we factor just numbers out, but we also can factor variables. So notice on number 2, I have 40 and 64. They have a greatest common factor of 8. But not only do they have the numbers, they have variables. Both of them have x terms. I have an x to the 8th power and an x to the 4th power. The maximum amount of x's that I can take out of both of these would be x to the 4th. Because I couldn't take 8 x's out of 4 x's in that second term. So x to the 4th, and then I can take a single y out of each one because they both have a y. So my greatest common factor is 8 x to the 4th y. Now I'm going to divide. What is 40 divided by 8? 40 divided by 8 would be 5. X to the 8th divided by x to the 4th. When we're dividing variables with exponents, remember we're just subtracting the exponents. So x, 8 minus 4 would be 4, so it's x to the 4th power. And finally, y divided by y is 1, so I'm not going to write that 1, because 5x4 times 1 would still be 5x4. Next, 64 divided by 8 is 8. X to the 4th divided by x to the 4th, and y divided by y is all 1. So this is my factored form. Remember, what we're looking for is if I take this term and multiply it and distribute it through, I should get this term as my answer. So I'm undoing that distributive property. Okay, moving right along. 1 and 2 only had 2 terms. 3 and 4 have 3 terms. You can factor a greatest common factor out of, it doesn't matter how many terms you have. I could have 4 terms or 5 terms, as long as I can find a common factor. 14, 35, and negative 7, all of those have a factor of 7, so I'm going to factor out a 7. And they all have m's. The maximum number of m's I could take out is 2, because the last term has 2 m's, so that's all I can take out. Now I'm going to divide each term. What is 14m to the 6th divided by 7m squared? 14 divided by 7 is 2. M to the 6th divided by m second. Remember, we're going to subtract, so 6 minus 2 is 4, so m to the 4th. Negative 35 divided by 7 is 5, and negative 5. M third divided by m second is m to the 1st. We don't normally write to the 1st power. Finally, negative 7m squared divided by 7m squared is a negative 1. Remember, it's not 0, it would be 1. We started with 3 terms, 1, 2, 3. We must have 3 pieces left inside that parentheses. Started as a trinomial, I should have a trinomial left over in my parentheses. This is my factored form. Okay, continuing right along. Problem number 4. 3, 5, and 8 do not have a common number factor. I cannot factor out a common number, but they all have a's and b's. I could take a single a and a single b out of each term. So what would be left over in the first one if I took a single a and a single b? I'd have 3b left over. I'd have negative 5a left over, plus 8. What was happening? A divided by a would be 1. B squared divided by b would be b. A squared divided by a would be a. B divided by b would be 1. So I only have an a left over. And finally, ab divided by ab is 1. So that leaves just 8 on the inside. So here is my factored form. All right, so that's greatest common factor. When factoring, when you are told to factor, you always need to look for that greatest common factor first, no matter any of the other methods we're about to go over. So when you have a trinomial, you're going to check to see if there's a greatest common factor first. And then if there isn't a greatest common factor, we're going to do, one of 2 methods. If you have your trinomial and a is equal to 1, we're going to do the x method. If a is bigger than 1, if you scroll down, you're going to notice in the next section, a is bigger than 1, we're going to do slide and divide. Now I'm going to remind you what each of those methods look like. Now you may have learned to factor differently. If you did, you still have to provide the work. You can't just give me the factored answer. You have to show me what steps you took to find those factors. Okay, so when we have a trinomial, which we do here on problem number 5, it has 3 pieces. And a is 1. The number in front of x squared isn't there, so it's 1. So what we're going to do is we're going to do something called the x method, where we put in the top of the x, we're going to say, what are 2 numbers that multiply to be 45? So I put a multiply dot and the number 45. In the bottom, I'm going to do a plus dot, and I'm going to put the number that b is. So we're looking for 2 factors, 2 numbers that we're going to put here and here. 2 factors that multiply to be 45, but add to be 14. Now, if you don't know those factors, that's okay. We're going to figure it out. It's 45, so if it ends in 5, divided by 5. 5 times 9 is 45. If I add 5 and 9 together, I do get 14. So my 2 factors are 5 and 9. Now, what do I do with that information? When I'm factoring a trinomial, the 3 pieces will turn into 2 binomials. The first binomial is going to be x, because we have an x squared. And then it's, because there is a positive 5, I'm going to put plus 5. And then times the other binomial will be x plus 9 from our 2 numbers we just came up with, 5 and 9. Those are our factored form. Now, what is this? What is a factored form? Remember, this is opposite of distribution. So if I was to FOIL this, remember the foiling method, x times x is x squared, x times 9 is 9x, 5 times x is 5x, 5 times 9 is 45. I combine like terms, I get this guy as my answer. So all I'm doing is I'm undoing the distributive process, or the FOIL method. All right, I'm going to go ahead and leave that there. I'm not going to re-multiply it back through every time, but you can re-multiply it back through to check your answer. Okay, looking at problem number 6. So first step is ask ourselves 2 numbers that multiply to be c, but add to be b. b is a negative 15. We need that negative with the 15 down below. 2 numbers that multiply to be 26, but add to be 15. If you didn't know the factors, we would start 26 divided by 2. 2 times 13 is 26. 2 plus 13 is 15. Now, how do we multiply to get a positive but add to be a negative? If 2 and 13 were both negative, a negative times a negative is a positive, but when we add them, we get a negative. So our variable is w, so I'm going to have w minus 2 times w minus 13. And those are our 2 factors. Now, could you have rewritten it? W minus 13 times W minus 2. Yes, it doesn't matter which order your parentheses are in. This is okay. We just can't rewrite it inside the parentheses. You couldn't have 2 minus W and 13 minus W. That does not work. Okay, moving on to our next ones. That was 5 and 6. Let's look at problem number 7. First step, 2 numbers that multiply to be negative 48, but add to be 2. So negative 48, add to be 2. Math facts, 6 times 8. 6 times 8 would multiply to be 48. If we subtracted them, I would get 2. To multiply to get a negative number, one of our numbers has to be negative. So when I add it and get a positive 2, I'd have to have a positive 8 and a negative 6 to get that positive 2 left over. So our 2 factors are c minus 6 times c plus 8. Now what we're doing is we are not solving yet. We are just practicing factoring. This is the major part of solving. In our next set of notes, I'll teach you how to go from this factored form to then get our solutions. All right, our next one. Two numbers that multiply to be negative 72, but add to be negative 1. 8 times 9 is 72. To add them and get a negative 1 left over, the 9 must be negative. So n plus 8 and n minus 9. Okay, our next one. Two numbers that multiply to be 36, but add to be 12. If you didn't know, you could go through a bunch of facts. 36 is 6 times 6. 6 plus 6 is 12. So a plus 6 times a plus 6. When you have something that repeats itself, we can write it as a plus 6 squared. And that is my factored form. All right, continuing right along. Two numbers that multiply to be 1 but add to be negative 2. 1 times 1 is 1. Negative 1 times negative 1 is 1. Negative 1 plus negative 1 is a negative 2. So n minus 1 times n minus 1, or n minus 1 squared. Okay, so far on 5 through 10, we haven't had a greatest common factor. Look at 11. All of those numbers, 2, 16, and 40, I can factor out a 2. So I'm going to factor out a greatest common factor of 2. Negative 16k divided by 2 is negative 8k. Negative 40 divided by 2 would be negative 20. Now that I have the greatest common factor factored out, we did GCF first. Now that I have the greatest common factor factor out, I'm then going to look at what are two numbers that will multiply to be C, our new C, and add to be negative 8, our factored trinomial. So two numbers, 2 and 10. 10 would have to be negative to get a negative 8. So when I factor out a greatest common factor, that stays out front. And then I'm going to have k plus 2 times k minus 10. And this is my factored form. All right, our last one in this section. All of these numbers are divisible by 5, so I'm going to take a 5 out. I'm going to have z squared minus 5z plus 6. I'm now going to ask myself, what are two numbers that will multiply to be 6 but add to be negative 5? So 6 has two factors. I either have 2 times 3 or 6 times 1. I need to add to be a negative 5, and I need to multiply to be positive. To be positive, I either need both negatives or both positives. Negative 2 times a negative 3 would multiply to be 6, but add to be negative 5. So my final factors are z minus 2 times z minus 3. And that is my factored form. All right, we're going to pause there for any questions, and then we'll move on to trinomials where a is bigger than 1.